So, have you ever been, stuck talking to an AI, trying to get
Oh.
help, maybe?
Oh, yeah, that feeling.
And it just feels clunky or slow, or it completely misses what you're saying.
Definitely been there.
Well, what if interacting with AI felt, I don't know, as natural as just talking to someone?
That's the goal, right?
Exactly. And today we're doing a deep dive into how AI is finally starting to make that happen, specifically through voice.
Yeah, and it's a really big shift. We've definitely moved into what people are calling a multimodal era.
Multimodal, meaning.
Well, for ages, generative AI was mostly about text, right?
Mhm.
Getting good at writing, understanding language.
Sure.
But now these models can understand and even create images, video,
Yeah.
and the really key one for this chat, audio.
Ah, okay.
And yeah, we've had transcription, speech to text and text to speech for a while. But this newer speech-to-speech stuff, that's maturing fast.
The speech.
Yeah, audio's finally hitting that point where it's, like, usable at scale,
Yeah.
especially for things that need to be super quick, low latency.
Okay, so for you listening, that's our mission today. A deep dive into building voice agents that actually work. We'll look at how much they've changed, what's going on technically,
The architecture's behind them.
and the really practical stuff, how to make them feel right, how to make them resonate.
Exactly.
Now, this is where it gets really interesting, I think. Just think back maybe 6 months ago. The audio models then.
Oof.
It
Yeah.
was kind of a painful experience, wasn't it? Like, remember trying that haiku thing?
Oh, I remember. Yeah, it was not great. We tried to get this older model to write a haiku,
Hmm.
and you could just hear the problems. It was slow,
So slow.
really robotic sounding, and it just completely fell apart if you try to interrupt it.
Right. We asked it for a haiku about, was it whispers?
Yeah, whispers. And it started very slowly.
Hmm.
And we interrupted, like, no, can you do stars?
And what happened?
It just kept going on its original track, but somehow got confused and ended up asking about sand.
Sand. After we asked for stars, it was completely brittle. That was the reality, like barely half a year ago.
And the contrast now is just stark. The models today are so much faster
In day.
and incredibly expressive.
Hmm.
They can actually sound emotional. You can steer them. They're way more accurate.
So that same haiku test now.
Totally a different story. We ran the same kind of thing. Asked for haiku.
About whispers again.
Yep, about whispers. And then interrupted. Actually, can you make it about stars?
Wow.
And it just did it smoothly, quickly, sounded natural, and gave a haiku about stars.
Wow.
You can really hear the difference. It's not just about being faster. It's that expressiveness, handling the interruption.
Yeah.
It feels reliable.
It makes you feel like you can actually talk to it.
Exactly.
Yeah.
We really think these models are at that tipping point now.
Yeah.
Good enough to build really solid experiences.
Okay, but that kind of leap, it's not just magic, right? There have to be changes in how they're actually built, what's happening, under the hood.
Yeah, absolutely. It comes down to the architecture. We're seeing two main ways people build these things now.
Okay.
The first is let's call it the chained approach. It's been around longer.
Chained.
Yeah, you basically stitch together three separate models. One does the audio input, the transcription.
Got it. Speech to text.
Right. And you feed that text to an LLM, a large language model, for the actual intelligence, the thinking.
Okay, the brain.
And then step three, you take the text output from the LLM and feed it to a text-to-speech model to generate the voice.
Ah, 3 steps. Sounds potentially slow.
It is. That's the main problem. It's slow across time, takes longer to get the full response out, and crucially, it can be lossy.
Lossy, like data loss.
Kind of. Semantic understanding can get lost,
Mhm.
like playing telephone. The meaning can get a bit distorted, bouncing between those separate models.
I see. Okay, so that's the old way. What's the new way?
The newer pattern is this speech-to-speech architecture. Think of it as one single unified model.
One model does everything.
Pretty much, yeah. Handles the transcription, the intelligence, and the speech output. Something like OpenAI's real-time API is an example.
And the advantage there is?
Well, first, it simplifies the whole system dramatically. Less moving parts.
Makes sense.
Second, it cuts down the time to output significantly. So it's really good for those low latency experiences we talked about.
Faster response.
Much faster. And critically, it holds on to that semantic understanding across the conversation better. Less chance of things getting lost in translation.
Okay, that sounds way better.
It often is, but it raises the big question, right? How do you actually choose which one is right for your project?
Right. Because it sounds like speech to speech is just superior, but maybe it's not always that simple.
Exactly. Understand the technical difference is one thing, but picking the right system involves trade-offs.
Okay, so what are those trade-offs? What do you need to consider?
We usually break it down into about 5 main areas. You've got latency, the speed,
Hmm.
cost, how much it runs you, accuracy and intelligence, how correct and smart it is, then user experience, or UX, how it actually feels to interact with, and finally, integrations and tooling, how easily it connects to other systems you might need,
Latency, cost, accuracy, UX, integrations. Got it.
and how important each of those is really shifts depending on what you're building.
Can you give an example?
Sure, think about a consumer app, something that lots of end users will interact with directly.
Okay.
There, UX and latency probably matter a lot. It needs to feel fast, engaging, attractive.
Right, you don't want users getting frustrated.
Exactly. Maybe super high accuracy on every single point or the absolute lowest cost isn't the top priority. It's more about that quick, expressive feel. Integrations are often simpler too.
So for that kind of app,
For that, a real-time API, that speech-to-speech model often works really well.
okay. But what about something different like customer service?
Right, good example. Now the priorities shift.
Yeah.
What do you think is most important there?
Accuracy. You absolutely cannot get an order wrong.
Precisely. Accuracy and intelligence probably jump to the top. You can't mess up order numbers, account details, things like that.
Definitely not.
And integrations and tooling suddenly become much more critical too. You need to connect to internal databases, CRMs, maybe phone systems using SIP.
All the back-end stuff.
Exactly. UX and latency still matter, of course, but maybe you trade a tiny bit of speed for guaranteed accuracy.
So in that case,
Well, the real-time API might still be the choice if that instant response is crucial. But you might lean towards the chained architecture if you need absolute control, determinism, and deep accuracy, even if it's a bit slower.
so it really depends on the specific job you need the agent to do.
It really does. You have to understand your use case first.
Okay, that makes sense. So we know the architectures, we know the trade-offs. Let's get practical. If you listening want to build one of these, how do you actually do it? What are the key patterns?
Right. So when we talk about an agent, we generally mean a few core things.
Mm-hmm.
The model itself, the instructions or prompts you give it.
The personality, kind of.
Yeah, that too. Plus any tools it can use. And then the runtime stuff like guardrails. Those pieces are common.
But for voice, some things are a bit different.
Yeah, a few things stand out. The system design choices we just talked about, obviously.
Yeah.
But also how you prompt it, especially for the voice itself, how you use tools, and definitely how you evaluate it.
Okay, let's break those down. What's a key pattern you see?
A really common one is delegation through tools.
Delegation.
Yeah. You might have a faster, maybe simpler frontline agent, perhaps using that real-time API, handle the initial chat, the easy stuff.
Like a receptionist?
Kinda, yeah. But then when a task gets more complex or needs more thinking,
Like checking a complex policy or accessing a database?
exactly. The frontline agent uses a tool call to delegate that specific task to a smarter model, maybe like the GPT-4 series models.
Ah, so it hands off the tricky part.
Right. We saw this in an example like returning a snowboard. The first voice authenticated the user, asked what they wanted to return, simple stuff. But then to actually check the return policy and process it, it paused. And a slightly different, maybe more capable agent took over for that specific task.
I see. So you use the right agent for the right job within the same conversation.
That's the idea. It keeps the initial interaction fast, but allows for deeper processing when needed.
Clever. What else is unique to voice agents?
Well, customizing the voice's personality is huge. With text, you shape the personality through words. With voice, you add this whole other layer.
The actual sound.
Yeah, the expressiveness. You can literally write in your prompts things about the agent's demeanor, the tone you want, how enthusiastic it should be.
So you can tell it to sound cheerful or serious or...
Exactly. And you can get quite specific. OpenAI actually has this fun website where you can play around with different voices and prompts and hear the results. It shows how much control you have.
Oh, cool. We should link to that.
Yeah, definitely. And for really complex voice behaviors, you can even use few-shot examples, basically giving it audio examples to mimic.
Okay, so lots of control over the sound and feel. What about those tools? You mentioned delegation. Any other advice?
Yeah, on strategic tool use, the general advice is start simple. Don't give one agent dozens of complex tools.
Keep it focused.
Right. Keep the number of tools per agent fairly limited. If you have lots of different complex tasks, maybe delegate to different specialized agents.
Like the snowboard return example.
Exactly. And the key thing with these handoffs is maintaining context. You have to summarize the conversation state so far and pass it along.
Otherwise, the next agent is lost.
Completely lost, yeah. Context passing is critical.
Okay. Now, you mentioned evaluation or evals. That sounds really important, maybe even more complex for voice.
It is, yeah. It's a huge part of making these things better. We usually think about evils in 4 main buckets.
4. Okay.
First, just basic observability. You need logs, traces of what the agent is doing, and the audio itself. Can't fix what you can't see.
Makes sense. Logging.
Second, human labeling. Honestly, this is often the fastest way to iterate, especially on prompts. Have people listen, rate the interaction, point out issues.
Real human feedback.
It helps you move much quicker. Third, you have transcription-based evals. This is more like traditional testing, A/B testing different prompts, or checking if the agent correctly performs specific business tasks based on the transcribed text.
Like, did it call the right function? Did it extract the right info?
Exactly. Using a rubric against the text.
Yeah.
But then, the fourth bucket is unique to voice, audio evals.
Evaluating the sound itself.
Right. Because text evals miss things like tone, pacing, intonation. Was it empathetic? Did it sound rushed?
How do you even measure that automatically?
It's tricky, but you can actually use other AI models like GPT-4 with its audio understanding to analyze those qualities in the generated audio.
Wow, using AI to evaluate AI audio.
Yep. And there's even more advanced technique, synthetic conversations.
Sounds futuristic.
It's pretty cool. You basically have 2 AI clients talk to each other, your agent, and another AI simulating different customer personas.
Like an angry customer persona or a confused one?
Exactly. And they go back and forth, generating tons of conversations automatically that you can then analyze at scale. It helps find edge cases.
That's really powerful for testing. Okay, one more pattern piece. Guardrails.
Ah, yes.
No.
Guardrails for safety. Super important, especially as these APIs get faster. You need to catch problematic outputs before they're fully spoken.
But if it's real time, how do you do that without adding delay?
The trick is you run the guardrails asynchronously. The text gets generated faster than it can be spoken aloud.
Ah, so there's a slight buffer.
Exactly. You have a little bit of time, a few hundred milliseconds maybe, to run checks on the text before it hits the speech synthesis part. You can control how often checks run, like every 100 characters or so. That's the debounce period.
Clever. So you can build in safety without killing the real-time feel.
That's the goal, yeah.
These patterns make a lot of sense. But are companies actually, doing this stuff well in the real world? Any success stories or lessons learned?
Definitely seen some cool applications. Lemonade, the insurance company, is a good example.
What did they do well?
They apparently focused really early on getting those evil guardrails and feedback loops set up for their internal teams, even when it wasn't perfectly scalable at first.
Why was that important?
Because nailing that evaluation process early allowed them to iterate and improve much, much faster later on. It paid off.
So invest in evils early. Got it. Anyone else?
Tinder's another interesting one with their RZ chat experience, that real-time thing in the app.
Yeah.
For them, the key was really focusing on customization
Yeah.
and making the voice feel authentic to their brand.
Brand realism.
Exactly. They knew a generic voice wouldn't cut it. That focus on matching the voice to their brand apparently made a huge difference in user experience.
So tailoring the voice personality, like we talked about.
Yep, making it feel right for their specific audience.
Okay, so it really feels like we are properly in this multimodal era now. Audio isn't just a novelty, it's right there with text, images, video.
Absolutely. It's a core pillar now.
And you mentioned things are still improving rapidly, like even just yesterday.
Yeah, funny enough, there was a quiet update to OpenAI's real-time API yesterday. A new snapshot, and initial reports suggest it's noticeably better again.
Wow, it's moving fast.
It really is.
Yeah.
Which honestly reinforces the main message here. Now is the time to build with this stuff.
Get ahead of the curve.
Yeah, there's a real first-mover advantage. It's not just about being first. It's about grabbing that user attention, building loyalty on these new, more natural interfaces. The tech is finally good enough for real, scalable applications.
The tipping point you mentioned.
Exactly. We're past the purely experimental stage for a lot of use cases.
So thinking bigger picture then, what does this all mean? This shift towards AI we can actually talk to?
Well, think about it. If you have AI that's not just processing commands, but is truly responsive, expressive, understands nuance in real time, It changes how we interact with technology fundamentally.
Less typing, more talking, more partnership.
Maybe, yeah, moving beyond just giving orders to having actual conversational partners. So the provocative thought for you, the listener, is this. What kinds of problems could you solve? Problems we maybe can't even imagine yet. When your AI can speak, understand, and maybe even feel a bit more human, what becomes possible then?